Hello everyone, me Arsha and welcome back to my channel that is Mathematics Scholar. In this video I will be discussing about the theorem which is based on congruence, that is the relation theorem, or the relation of a congruence is an equivalence relation. As you can see on the screen, this is the statement of the theorem, so let's prove the theorem. Okay. Uh, a relation is said to be as an equivalence relation if it is reflexive, symmetric, and transitive. So it means that these three properties, that is reflexive, symmetric, and transitive, if these three properties if it is satisfied, then only we can say that a relation is said to be as an equivalence relation. Okay, the relation of a congruence, sorry, if the relation of congruence is an equivalence relation, all these three properties should satisfy. Now one by one we'll go and we'll prove that it satisfies reflexive property, symmetric, and transitive property. Okay, so I'll write, we know that, as you can see on the screen I'm writing, we know that m divides 0. M divides 0. M divides 0. What is the meaning of m divides 0? M divides 0 is equal to 0 divided by m. We know that m divides 0, where m is a positive integer. So the meaning of m divides 0 is nothing but 0 is divided by m and the value will be 0. It is obvious, right? You take any 0 divided by any number. Here I have taken a positive integer, so it is obviously it is 0 only. This I am going to consider, that is that I can write it as m divided by a minus a. Yeah, it is obviously it is possible. A minus a, if we go back, it is m divides 0 only. A minus a, why I have taken here? Why I have taken a minus a? In the sense we need to prove that a is congruent to a mod m, where integer what I have taken here in this case is a, so I am taking a minus a. Okay, so by the definition, therefore by definition of congruence we have what we have, a is congruent to a mod m. So this is by the definition I can write down a is congruent to a mod m. That is the required result, right? That is the thing we need to prove. As you can see here, this is a reflexive property. So if you have still doubt, go and watch the first part of this video where I have explained the definition of congruence with an example. You'll come to know. So this is the reflexive property. Let's move on to the next one, that is symmetric property. Now the symmetric property, so I'll write it over here. As you can see on the screen, what is the symmetric property? What is the symmetric property? If A is congruent to B mod M, then we are supposed to prove that B is congruent to A mod M. This we are going to consider, and last we are going to prove the last one. Okay, we are going to prove this. This we are going to consider this thing. At last we are going to prove this one. So I just write it over here. I'll just consider, since A is congruent to B mod M, that they have actually given, we are supposed to prove that B is congruent to A mod M. Okay, this by therefore by the definition of congruence I can write down this as M divides A minus B. This is by definition of congruence. Okay, that is possible, right? Still, that implies M divides minus of A minus B. Why I have written here in the sense, in congruence we have a property that is M divides A is equal to M divides minus A. This is one and the same. Means the meaning is here, actually the meaning is uh, M divides A is also divides minus A. That is the meaning of that. So I can write down the positive number where M divides that positive number, that is A minus B, some positive number. That implies M divides negative of A minus B by this particular property. Okay, this further implies M divides what is this is minus A, this minus into minus is plus B. That implies M divides B minus B. This I can write since it is positive, so I have taken B here, and negative A I have written here. In this way also I can write it down. Therefore, this by the definition, again by the definition of congruence, I can write down B is congruent to A mod M. That is the result we need. Since we have taken here this, and at last we have proved this. Okay, so this is your symmetric property. So this and this together, it is your symmetric property, where you have taken if A is congruent to B mod M, and at last you are going to prove that B is congruent to A mod M. Okay, this is the required result. Let's move on to the third property, that is a transitive, where we are actually considering if A is congruent to B mod M and B is congruent to C mod M. See, this thing we are going to consider, A is congruent to B mod M and B is congruent to C mod M. These two things we are going to consider, we are taking, and at last what we are going to prove? We are proving this one. This is A is congruent to C mod M. So, okay. So what I am supposed to consider? These two things. Since A is congruent to B mod M, see these two things I am taking over here, and what is another one? B is congruent to C mod M. These two things I am going to consider. At last I am going to prove A is congruent to C mod M. So let me write down here. Just a minute. Okay. This by the definition I can write down. Therefore, M divides A minus B. And this one I can write it down and M divides B minus C. These two things I have written here by definition of congruence. I can write down, right? So that implies M divides A minus B plus B minus C. Why I have written, how I have written, in the sense we have one property in a congruence, that is if A divides B and A divides C, then I can write down A divides B plus C, By using this property, I have written this thing. I have used this property of congruence. So that implies m divides what is going to cancel here, plus b and minus b. So it is a minus c. Okay, that implies by the definition of congruence, again I can write down this as a is congruent to c mod m. This is your transitive property. Transitive property, what are the things you're taking here? This is you're taking these two, and at last you are going to prove this one. This is your transitive property. So we have um, we have proved it has reflexive, symmetric, and the transitive property. This one, this one, this one. So at last I can conclude, I can write down a relation is said to be an equivalence relation. That implies, I'll write down, that implies the relation of a congruence is an equivalence relation. Okay, that's it. It's very simple. It's very simple. They can usually they'll ask for this particular the theorem for 4 to 5 mark together, 4 to 5 mark. Otherwise, another way how they can ask is prove the reflexive property, prove the symmetric property, prove the transitive property. In that way also they can ask prove that A is congruent to A mod M. Prove that if A is this one, then prove that B is equal to A of mod M. Prove that if A is congruent to B mod M and B is congruent to C mod M, then A is congruent to C mod M. In this way also they can individually they can prove. So if they ask individually, they can ask this for 2 marks and this for 2 marks and this for 2 marks. It's very important and it is very simple to understand. If you have any doubts, you can write down in the comment section. It is given, or you can mail me to my email ID. I hope the proof of the theorem is clear or understood for you. Please like and share and subscribe to my channel for more such videos, and also hit the bell icon so that you will get the notification whenever I upload my new video. And also comment in the comment section. Thank you all. Keep smiling and keep learning. Bye bye.